What is up, guys? Welcome to another video. My name is Shaik and today I'll be going over one-shot learning. So you can see this one-shot learning being used in phones, like facial recognition. Recognition, you don't give it thousands of images of your face, you just give it one. So basically it's some form of usually it's like a 3D image in the case of iPhones, and in this one I don't think this is using AI at all. Let's figure out how this works. For a regular deep learning problem, what you would do is you would give it lots of data. You would give the neural network lots of data and lots of computational power as well, and it's going to pick up some patterns from the data, and we can use these patterns to predict for a new set of data. So I was working on this dog breed project a few days ago, and basically what it was is when you give it one image, it's going to be able to predict what the breed is. How you would train this model is by either using transfer learning or starting from scratch. So transfer learning basically, if you want to learn more about transfer learning, I'll link something below. Let's go back to what we were talking about, which was one-shot learning. So one-shot learning, you can do the same thing but with one image. I don't know why one-shot learning is called one-shot learning, because it's not learning anything. The neural network is already trained. It can recognize some patterns in the images already. So let me just show you an example right here. So this is a face net, right? And this was trained on celebrity faces. So we can consider this FaceNet like a good neural network for our problem right here, which is facial recognition, right? Now, for faces, right? Anything regarding faces, it can identify the patterns in the faces. For example, the face color, the wrinkles, and the eyes. I don't know. So basically, that's what it can recognize. It knows the patterns there, and these are its weights. So we can load these weights in, and so let's say this is the image of my face, right? And if we pass this image through this neural network and get the predictions out of it, and store those predictions in this variable right here, and let's say this is an image of someone else, and we're gonna store the predictions, right? Now this is so let's say this is another image of my face, and so basically this is it. Get the image, pass it through the neural network, get the predictions, subtract the predictions, and check which is the lowest. So if we subtract these predictions with my face predictions, so the neural network will output something similar, and because it's recognizing patterns in the faces, right? So it's gonna output something similar, and the difference between these two is going to be low, and the difference between these two will be high. Is we're just passing the image to the pre-trained network, and then comparing this image to the image when you try to unlock your phone. So that's how facial recognition works. And actually, you don't need two classes. You just need one class. You just need one image for your facial recognition. If you have like more than one class, right? If you wanna predict, like, let's say cats and dogs, you can do that too. You can have an image of the cat, feed it through the neural network, get the predictions, and then you can do some multi-class classification as well. The test. So look, this is how it is, right? We create this list of predictions, and we subtract these between we subtract this from the test image prediction. And what we're gonna do is we're just gonna compare the differences, right? Difference between this and this and this and this. So we're actually gonna do a square on the difference because we don't want any negative values. So this is how it would look like, but we're not gonna use like a cat image here because this will not work well on cat images, I think. So yeah, that's about that, and that's how you can use one-shot learning. It doesn't apply just for images. You can do something related with audio. You can work with some audio data if you're using like an LS pre-trained LSTM or recurrent neural networks. So those are the names of the neural networks that we use for audio and sequential data, audio, text, stuff like that. I wanted to explain how one-shot learning works because I'm using one-shot learning in my new project, and basically the project is comparing Silicon Valley characters to your image. So I saw this Instagram filter that my friend Hanan Mustajab did, and picture. So my friend created this Instagram filter. His name is Hanan Mustajab. He posts some amazing content on computer science. If you're interested, you can follow him. And it was random. It was random. Well, I wanted to legitimize that filter. This is my try, and I just wanted to document through that. So let's get into it. So the first thing I did was download all the faces of the Silicon Valley characters. Actually, I downloaded the images and I cropped the faces, and now we're ready to use this for our problem. So let's go. So I needed a way to store the predictions and access them easily. So I made a dictionary. I have the label as the key and and the the predictions as the value. So this is what I have. I processed the test image. This is my image right here, and I collected the predictions as well. And after we do that, what we do is we loop through the entire predictions and calculate the difference and square the difference and then average it. And then what you do is you find the one with the least difference and print the label out. So that's what I did, and that's pretty much it. Guys, it is finally the time to test my creation. So let's see what character, let's find out what character of Silicon Valley I look like. Let's find out. It is time to tick this one off as well. There we go. And back after some debugging, and let's just run the code to see what character I look like. Yes! Yes!
Oh wow, microdrones. They just closed 17 million in seed funding.
I even tested this on my friend Swami. Hello. So I explained him the project, and then what we did was took his image, fed it to the neural network, and it returned Monica, which is a female character. Then I used another image, and it returned Russ Hanneman. And I don't know if it was because the neural network considered the shadows as the beard, but or the face structure, So those might be the reason that contributed to the prediction. So that was it, guys. That was a fun little project. You can test it out. I'll link the Colab Notebook in the description, and I'll tell you how to install face net and get the weights in the description. If you're testing this out, I'd recommend using a squared, small sized image because of the way this is resizing it to 160. So check out the description for more information. But this is it, guys. I hope you've enjoyed. If you've noticed that I've put up make a colorful app in my next steps list. I'm not going to do that now because I have my exams coming up after lockdown and I haven't studied anything, so I'm gonna pause this for now. So we're gonna make an app. We're gonna make a web app after the exams. So stay tuned. Stay safe. Stay safe. Keep learning. Sayonara.